Okay, this is Module 2, Use Segments and Congruence. A lot of this is dealing with measurements and with segments and the difference between lengths and actual figures. So the first term we have, we know, and we did this in the previous module, but this guy here, AB's segment, is used to name a line segment. It has two letters and it has the line segment notation above it. If you have an M in front of this, that's going to actually refer to a number or a length. So the measure of AB's segment means the measure of segment AB and refers to a physical number, like 4 or 7 or something like that in terms of a length. Same deal here. The only difference is this guy here does not have an M in front, and it also does not have a segment above, and that basically indicates that it's referring to a length. So AB without any notation above it means the length of or distance to or from A to B and refers to an actual number. So these two guys are just different ways, these two are different ways of saying the same thing. So example 1, use a ruler. Model example, we have find the measure of AB's segment to the nearest tenth of a centimeter. So we put your ruler up to the segments. You start here and you basically count and measure. This ends up being 5.2 centimeters. Now a couple different ways of indicating it. You could say the measure of AB is 5.2 centimeters. You could say AB equals 5.2 centimeters. You could also say the measure of AB's segment equals 5.2 centimeters. So in this one, the guided example, again we measure, it says find CD's length to the nearest tenth of a centimeter. So we look at this and we see that it measures 4.5 centimeters. So again, the two different ways of putting the measurement, you could say CD's length equals 4.5 centimeters. Or you could say the measure of CD segment equals 4.5. It really doesn't matter which one, both indicate length, both refer to a number. So, something that is very important in abstract geometry is something called a postulate, and we're going to go more into detail with that in later modules, but we have our first postulate, which is called the segment addition postulate. Now a lot of this is intuitive thinking that you have probably done in middle school, but we're going to actually take it a step further, and the main reason is because we have to start thinking abstractly about geometric figures. So I have segment addition postulate. If B's point is between A and C, we can conclude that AB's length plus BC's length equals AC's entire length. So for example, this length AB plus this length BC is going to equal the entire length of AC. And the converse is also true as well. If we conclude that AB plus BC equals AC, then B is going to be between A and C. So in the example, in the model example, it says use the diagram to find AC's length. And I know for a fact everybody's looking at this and it says the measure of AC is 600 meters. And that's exactly right. It's a very easy question, but in order to understand abstract thought, what you have to do is to make sure that you can apply it to easier examples. So here's our easy example. And you take AB's length plus BC's length and set it equal to AC's entire length. And we use something called substitution. AB's length becomes 380 meters plus BC's length, which becomes 220 meters. And that equals AC's length. And when we solve, we get 600 meters equals AC's length. And that's using the segment addition postulate. And in later modules, we're going to be using the segment addition postulate involving proofs. Now, in the guided example, it says use the diagram to find BC's length. Well, we are given 21. That's for AB. We are also given that the entire length is 36. And I'm sure everybody's looking at this and they're like, okay, well, yeah, the missing length has to be 15. Okay. Try to apply the abstract segment addition postulate. We don't know what BC's length is. If you want to introduce a variable, fine, you can call it X. I'm going to keep it as BC just to keep it consistent with the formula. So we have AB's length plus BC's length equals AC's length. And I plug in everything that I know. AB's length is 21 meters. BC's length, we do not know, so we keep it as unknown. And AC's length is 36 meters. And now you solve it algebraically by subtracting 21 on both sides. And solve, and we come up with, so I'm running out of room, we have BC's length equals 15 meters. And that's applying the segment addition postulate. Okay, moving on. So we have the difference between lengths and congruence. We're going to say the two segments are going to be congruent segments if they have the same length. So if it is determined that their measurement is the same, you can say that the two segments are going to be congruent. And the symbolism for that is going to be this notation right here, this dash mark. If you see that two segments have the same notation or the same number of dash marks, that indicates congruence. And the main thing to decipher is that lengths are going to be equal. So for example, in this case, AB's length is equal to CD's length. But the segments themselves are going to be congruent. And it's a notation thing that you have to keep straight. So for example, AB's segment is congruent is this symbol here, to CD's segment. Okay, so I have here, it says compare segments. So it says plot J is -3, 4, K is 2, 4, L is 1, 3, and M is 1, -2 in a coordinate plane. And then it says determine JK's segment and LM's segment are congruent. So determine whether they are congruent. So JK is this point here, or is this line segment here. When you plot the points J and K, you connect them with a line segment. We have this. Now, there is a complicated way of figuring this out. I like to just count. So I say, okay, well, I've got 1, 2, 3, 4, 5. So JK's length is a length of 5. So what about LM's length? Well, now we have to actually plot LM. So we have LM is the point 1, 3. And M is the point 1, -2. Now, again, keep it easy. We'll go through a distance formula in a later module, but for now, you can just count and say, okay, well, LM's length is 1, 2, 3, 4, 5. So I can say that LM's length is 5. So I see that LM's length is 5, and JK's length is 5. Since they equal the same length, I'm asked how do JK's segment and LM's segment compare? Well, we know that JK's length is equal to LM's length, and that's by a property that we'll actually learn in Chapter 2 called the transitive property, but don't worry about that yet. But the segment statement that we can make is JK's segment is congruent to LM's segment. And that's it.